Okay, welcome back everyone. We're going to wrap up this unit which covered rotational kinematics and rotational dynamics and also angular momentum. And the last topic that we're going to talk about for just a moment is the idea of precession. Now this isn't covered very strongly on the AP test, but it is pretty important to know about and it's very interesting. So what we want to figure out is what happens to an object with angular momentum when an external torque is applied. But before we talk about that, I'll just tell you a very quick story. The North Star, Polaris, didn't used to be the North Star. It used to be another star called Thuban in the constellation of Draco. And what happens over time in about a 26,000 year cycle is that the Earth is actually wobbling on its axis. And because of this wobble, the Earth's North Pole points at a different place in space. And this is a type of precession similar to what we're going to be talking about. So, remember that we can write Newton's second law in terms of momentum. F equals dp dt. P being momentum, F is force. And now let's substitute torque and angular momentum, and we get torque equals dl dt. So tau is torque, L is angular momentum, and T is time. Now in the last video, we looked at what happened when torque was equal to 0. This meant that dl was 0, so L initial was equal to L final. But if we do have a torque, then this torque changes L with respect to time. So torque will actually increase the angular momentum when they're parallel to each other and decrease it when they're anti-parallel. In any other situation, what torque will do is it will change the direction of angular momentum. And this is what we call precession of spinning tops and planet Earths. Okay, so here's a simple example if torque and angular momentum are parallel. Okay, so if a disk is rotating like this, what's the direction of the angular momentum? And we can recognize that angular velocity is actually a vector, so whatever direction the vector is for omega, it'll be the same for L, and in this case, it's out of the page. Okay, I'll erase that so you can see it. Okay, L is coming out of the page, and let's think about a force applied in this direction. What direction is the torque? Well, fingers go in the direction of R, we curl towards F, and the torque is also out of the page. And this is just going to increase the angular momentum. Okay, so the torque and the angular momentum point the same direction. Okay, what if they're anti-parallel? So omega is clockwise. Well, in this case, angular momentum is into the page. And if we apply a force going down, then that's going to give us a torque that tends to come out of the page, and the rotation will slow down. So that's okay. But now, what happens if torque and angular momentum are not aligned? So here's a spinning top where we have angular momentum and torque interacting in a pretty complex way. Torque is going to change the direction of the angular momentum, which is going to cause precession. So what you see right here is omega. And so in this case, omega is actually a vector, and so is L, that points outwards. Remember, L equals I omega. And you can use your right-hand rule with this direction of rotation to come up with that. Now, imagine that we have a force of gravity, okay? And this force of gravity is going to cause a torque. Now, from this diagram, we can see that there's a torque that is into the page. So now the torque and the angular momentum are at a right angle. Okay, this is going to cause a change in angular momentum, and it's actually going to cause this top to precess. So the point right here will stay in the same place, okay? But the axis will point in different directions. And the axis will be pointing in a different direction along this circular path, okay? So at some later time, L is actually going to be going this way as the top is spinning like this. And that is the concept of precession. And this happens to the Earth, and it's why the North Pole was pointing at one star a long time ago, and now it's pointing at another. Okay, so that's it. We have covered a lot of ground in these videos on rotation. Rotation makes up a huge part of mechanics, so I really encourage you to go back and study any parts that don't really make sense. And remember that there's a lot of practice problems, a lot of free response and multiple choice problems to practice as well. Okay, so we have 2 more units to look at in mechanics, and next time we're going to start studying universal gravitation.